This is the third video in an introduction to a first course in modelling, analysis and control, and here we're going to introduce some concepts of closed loop control. So the first video introduced the concepts of systems, behaviours and performance, whereas the second video demonstrated that simply estimating the required input may fail to deliver the desired output behaviour. So how do we control behaviour then? So having decided what behaviour means and what behaviour we would like, the next question is, how do humans ensure that systems behave the way we want them to? How do we ensure the speed of a car is correct? How do we get the temperature of a shower correct? How do we balance while walking and not fall over? So we use this concept called feedback. So here we're going to introduce how we do it. First of all, we monitor or measure. Where is something at the moment? Is it where we want it to be? If not, let's change the input a bit. Okay, having changed the input, let's wait a bit and see what happens, what's the effect. And then we start the process again. Having waited a bit, we monitor or measure again and say, is it where I want it to be now? Do I need to change the input a bit more? Let's wait a bit more. And you'll see we've got a loop. We go round and round and round. So the core things we have happening here are measurement, decision or adjustment of the input, and effect. And we have a continuous enactment of all three elements. Let's try this then on the example of a shower or bath. In order for a comfortable shower, the temperature of an outlet flow must be around 40 degrees. So we're going to mix hot water at about 70 degrees with cold water at outside temperature by opening and shutting taps to change the flow rates. And the key question is, will the human method of monitor, adjust and wait, will this feedback loop work? Well, you've all been in a shower, you know what happens. You turn the hot tap and the cold tap a certain amount, and then you wait a bit, and then you try the temperature and say, oh, it's a bit cold, let's turn the hot a bit more, and you wait a bit and say, oh, well, maybe it's a bit hot now, and you turn the hot down a bit. And basically, after just a few adjustments, the shower is lovely, and we're happy. So the human methodology is working. So let's try something on a very similar system, an industrial heat exchanger, okay? Which basically the idea is to get the temperature correct. And we also want to look at what happens when disturbances happen, okay? When flow rates change and so forth. And what you will see is that with no or very slow changing disturbance, the human approach to feedback works very well. So here's the heat exchanger, okay? So what we'll do is we'll start, okay, and we've got a desired temperature here of, let's say, 30. So what I'm going to do is I'm going to guess the steam flow rate here, you can see, should be about 10.15. Now I'm looking at this and I'm saying, oh, it's going to overshoot a bit. Maybe that's a tiny bit too big. Let's reduce it a bit. Let's reduce it a bit. Okay, and you can see, oh, let's reduce it a bit more. And you can see what I'm doing. I'm basically looking and saying, well, is it a bit too big? Is it a bit too small? And I'm making big adjustments if I'm a long way off, small adjustments if I'm a small way off. And you can see I've now got the steam flow 9.075, and it's just about correct. I'm not too worried about decimal places. So our human process has worked. Now, what if we get some form of disturbance? So the inlet temperatures change. You see, oh, it's going way too hot now, so let's reduce the steam flow. And you can see very quickly I can start bringing it back now to where I want it to be. Okay? I can change other disturbances. What if the flow rate through the thing changes? So now I've made it a lot bigger. Oh, I need much more steam. Much more steam. And you see very quickly I observe what's happening and I make a change. Okay? And this is what humans do. They observe what's happening and they say, do I need to increase or decrease? And how much do I need to do it? But you can see we can manage to control very, very effectively. Okay, so let's kill that one. So next one, cruise control. So what would you do with your throttle to achieve 20 meters per second? And can you cope with changes in slope and car mass and so forth? And again, what you'll see is that with no or very slow changing disturbances, the human approach to feedback is pretty effective. So let's find the car. Here it is. And let's choose open loop and start the simulation. So there's the car, it's not going anywhere. So I want to get, say, 20 meters per second. So I'm going to guess, oh, let's move the throttle a bit. Okay, I've moved it to 40. Is that enough? Well, that's far too much. You can see I'm going very, very fast there. So I've reduced the throttle again. So reduced it down to 20. Is that going to be about right? Oh, I'm going a tiny bit too slow. So let's increase the throttle a tiny bit. Okay, is that enough? Now this GUI is slightly slow, a bit more than 21 maybe. And you can see these small adjustments, and gradually I'm going to get to the speed that I want. Okay. Now, what next? So I've got to the speed I want with these small adjustments, it's worked. Now what happens if we end up with a slope in the road? So let's add a slope, update parameters. Okay, so now what we want to know is the speed going to change when the slope on the road changes? And are we going to be able to cope with that? Okay, there you go. The slopes come in. You see I'm losing speed. Let's increase the throttle. Okay, so there's a bit of a lag in this system, in this interactive GUI, which isn't ideal, but again, that's not such a bad thing to see. How would you deal with this in practice when there was a lag in the system? So I have up the throttle, it's just not kicked in yet, and in a minute you'll see there you are, it's kicked in, and I've kicked in a bit too much, so let's reduce a bit. And again, you see the idea, although here it's really in slow motion, okay, which isn't ideal, but you get the idea that I can make these adjustments, I can see the impact, and gradually I'm going to get the speed back to where I want it to be. Probably I'm going to need a slightly more adjustment. It's going to go down in a minute. It's clearly just acting very slowly. There you go, it's going down, and you see as it goes down I can see a change in the speed, and I'm going to say, oh well, maybe that's not quite enough, I need to go down a bit more. And yes, it's in slow motion, but you can see what's going on here. Okay, this is really good at emphasizing. You monitor, you adjust, and then the weight. You notice this weight impact, and that's what humans often have to do. We have to wait and see, has our change had an impact? Is it enough? Do I need to make another change? Okay, so the weaknesses of open loop control. Why can't we control car speed with our eyes shut? Why can't we control the temperature of mixed flow without a temperature sensor? All these systems lack a measurement or observation. That is a mechanism for checking what the system is actually doing and thus deciding on an appropriate action. So why does feedback work? Well, the key thing is feedback introduces measurement. The input depends upon the measurement and is continually updated and corrected. So we measure, am I in the right place? Yes, do nothing. No, change the input. And a core point here is that in general, we can control behaviour effectively if and only if the input depends upon the output measurement. So the input that we're choosing actually depends upon what we're measuring. And this is called a feedback loop because the input depends upon the output, that's our decision process, and the output depends upon the input through the system dynamics. So you can see it's a loop. Okay, so we've got this interdependence between the inputs and the outputs. Conclusions then. For many systems, it's important to control the output to a specified value and with specified behaviour, irrespective of uncertainty in model parameters and external disturbances. Humans use a measurement, decision, action feedback loop to achieve this. Okay, and what we've shown is that works, and this module is going to focus more on the mathematical and analysis tools that students will need to introduce feedback in a more systematic fashion. So obviously I've just shown you some conceptual pictures and ideas here, but we need to be a lot more systematic and analytical in how we tackle this.